Hello everyone. Today we'll continue with Unit 5, okay, and we will deal with searching algorithms. Okay. One of the most common and time consuming operation in computing is searching. Okay. So we have dump of data and to extract one element or one file what we require, it takes lots of time to search and retrieve the data, right? So it is most common and time consuming operation. Okay. Now what is searching? Searching is nothing but a process that is used to find the location of a target among the list of objects. So here the list of objects might be files, it might be an array, or so whatsoever, depending upon what we are looking, the element what we are searching for. Okay. Next, a very important thing is the time required for this search is huge. That is there is uh, very much importance of writing a data structure such that the storage of the elements is done proper. Once the storage is done appropriately, the search or the retrieval process becomes easier. That is what we are trying to understand in this particular data structure lab, that the storage of data is important because the main because we have to retrieve the data appropriately, right? So which data structure we use, that all becomes very much important in case of our searching process. Okay, so what we say is many a times it is required to search a large amount of data to find one information. Of course, if we want to find a single file, sometimes we require to search an entire 1,000 files. Okay, but if I use an appropriate algorithm so that I reduce my time of search, that is what is the leading point or the main point what a programmer has to look for. Okay, searching methods are governed by how data are stored in computer. Certain methods of organizing data make the search process more efficient. Okay, so the way we store the data really matters. Okay, now here in our syllabus we are going to study two types of search, that is the sequential search and the binary search. Okay, now there I was talking to you about data structures, right? So how we state that point? The algorithm used to search a list depends to a large extent on the structure of the list. That is, searching methods are decided by the data structure used to store the information. So we also studied in a first lecture, that is, why do we require data structure? So here it is. In case of your search algorithms, to retrieve the data from our computers, from the DAMs, it is very important to understand how the storage takes place. How to store appropriately is of much importance for the retrieval of the data. Okay, so now going ahead with two types of search, we are going to study sequential and binary. Okay, the sequential search can be used to locate an item in any array, whereas the binary search requires an ordered list. Okay, so let us look into a sequential search or a linear search first. This relates to experiment number 9. Okay, the sequential search is the simplest of search. In this particular search, each element of the array is compared with the item that has to be searched for. Okay, until a match occurs. For example, if you have a list of numbers 1 to 10 and if you want to search element 5, this number 5 is compared with each element in the array. It is compared to 1. If they match, no, then it's compared with 2, so on until it finds a match. Okay, hence it is the simplest form of search. Okay, here you do not require any ordering, that is, you do not require the data to be in ordered fashion because it is gonna search each and every element in the array. So the linear search is the only way, or maybe the only way, to find anything in the unordered list. Okay, so now let us look into the algorithm of the linear search. for the linear search program. Okay, so what we do is we start from the leftmost element of the array, right? Then we compare this particular element, that is what we want to search, with each element of the array. Okay, so now if this x, that is the element what we want to search, if it matches with the element, we return the element. If it doesn't match, we print a message saying that element not found. Okay, or we return -1. If not, we set a flag and decide on that particular flag. Okay, so let us look into the program. So what are we doing in this particular program? It is a simple flow. Okay, we scan for the elements. Okay, Cin. Okay, next we scan for the element what we want to search, that is stored in x. Now for this entire array, we check each element, that is if array of I is equal to that key or what element we want to find which is stored in x. If it is true, we set the flag is equal to 1 and then we come out of the loop because we found it. We did not search the rest of the array. I got a match, we quit it. Let the rest of the array need not be searched, right? It doesn't make sense. So until match is found, it is searched. So what we say, if flag, print element, if flag is set, we print element is found at this particular position I plus 1, else we say element is not found. So how does the input and output look? Let us look into this. Okay, so we are going to scan 5 elements. See, 11, 12, 11, 22, 33, 44, 5. Now we want the element to be searched to be 44. Okay, so now what happens? 44 is compared with 11. Is it match? No. It is compared with 22. Is it match? No. It is match. It is compared with 33. Is it match? No. It is compared with 44. It is matched? Yes. Now what it does? The flag is set and hence we give this message, element is found at position 4. Okay, this is how the linear search works. Okay, now let us look into what is binary search. Now in case of linear search, it is very slow. Why? Because we need to compare the item with every element, right? What element we want to search or what item we want to search, we have to compare it with every element. Imagine if it is if we have array of 100 and if the element you want to search it is at 100th location, you have to search for the entire 99 elements and then finally at 100th location you will find the element, right? So hence it is very much it is time consuming and it requires much time to search. Okay, though it is the simple one. But in case if the array is not ordered, linear search would be may be a solution to search a given element. Okay, now in case of binary search, we have to make sure the array is a sorted array, okay, or the list is the sorted list of elements. So we must make sure if we are taking a numeric array, it should either be in an ascending order or a descending order, but it should be a sorted array. Okay, so how does this particular binary search works? Okay, very simple. It works by repeatedly dividing in half the portion of the list that could contain the item until you have narrowed down to the possible location to just one. Okay, then compare the item being searched with the item at the middle of the sorted array. If they are equal, the search has been completed successfully. Okay, if the middle item is greater than the element being searched, the search process is repeated in the first half of the array. Otherwise, it is repeated in the second half. So as simple as that. What we do is, first there is a list. We find the mid element. Okay, and then this if the mid element is greater than the item what is going to be searched, then the search process is repeated in the first half of the array. Otherwise, the process is repeated in the second half of array. Each time a comparison is made, then the number of elements yet to be searched is cut into half. So we can see that, right? What happens is first mid element is found out. So if the item what you want to search is greater, or say if the middle element what you have retrieved is greater than the item what you're gonna search, then the first half of the array is gonna be searched for. So that means you are reducing, right? You need not look at the other one. Okay, now if for example if there is a sorted array 10, 11, 12, 13, 14, 15, now you what you can do is you find the middle item, then you compare if the key or the item what you want to search for, whether it is greater than the mid item or less than the mid item. If it is greater, you search on the other half. If it is less, you search on the first half. So that is how you carry on your search process. Very simple one. Okay, so each time a comparison is made, the number of elements to be searched are cut into half. That's the reason. Because of this division of the array to be searched into two equal parts, this search is called as the binary search. Okay, now binary search we are going to implement it using recursion. So let us look into the algorithm once again how it works. Okay, so first of all, compare x. X is nothing but what you want to search. We can call it as an item. Okay, compare x with the middle item of the middle element of the sorted array. Okay, so you have an array which is sorted. You find out the middle element. Then now what you do, you compare the item what you want to search for with this particular middle element. Okay, this is your first step. Next, if your item, that is if x matches with the middle element excuse me, that means you have found the element is found at that particular location. There is a match. So what you do, you simply return the mid index, that is you find that element at that particular location. Else if x, that is if your item is greater than the mid item, then x will only lie in the right half of the sub array. Correct, because it is an ascending array. If your element is, or if the item what you want to search is greater than the mid element, that means it will of course lie in the right half, and your search has to be carried out in the right half. Okay, next, else if x, that is the item you want to search for, is smaller than the your middle element, what we do is we search in the left half. Okay, until we find the appropriate item at a particular location. Once we find, we print it. Right, so let's look into the program. Here again we scan for the array, cin array. Okay, we scan for the element that has to be searched. We can call it as an item. Here we save it in an variable called as x. So x has the value of what you want to search for. Then what we are gonna do is we are gonna call a binary search function. Okay, I'm gonna pass this array, and we are gonna pass that is the search begins from the 0th index till the end of the array n-1, that is size, right? And we also pass the element what we want to search for. Okay, so once this function is called, all the parameters are passed here. Okay, so as our first step says, we have to find the mid of that particular array. So the mid location is found out, the mid is found out, the mid element by adding first plus last minus first divided by 2. Then we compare if the mid is same as, that is the element at the mid location. Okay, this mid is nothing but the location. So array of mid means you will get the element itself at that particular location. So if it matches with your item, that is x, then you simply return the mid. Okay, else you now compare array of mid if it is greater than x. If it is greater than x, again you repeat the binary search process, right? But now where you're gonna repeat the binary search process, it depends upon this particular condition. So if x is less than, so here what we mean, array of mid is greater, so we are gonna, here we have already said, right? Note this condition. If array of mid, see, if the middle element is greater than the item being searched, the search process is repeated in the first half of the array. Otherwise, the process is repeated in the second half. Exactly the same thing we carry on here according to the algorithm. If array of mid is greater than x, we try searching here until we find a match, else we search in the other part of the array. Okay, first we search the left subarray and then the right subarray. Correct? Okay, this is how the program works. And here important point is, if the match is found, we return the mid, that is the location. Correct? If not, if anywhere in the array we don't find the match, we simply return -1, and based on this result we check. If the result is equals to -1, we say element is not present, else we say element is present at that particular index. Okay, this is how this program works. Now let's look into an sample input output. So you scan for 5 elements, 55, 66, 77, 80, 899. So make a note, this is a sorted array. So this is an ascending order. Okay, so you want to search for 66. So what we do is, what the algorithm does, it finds the midpoint first, then it checks, it compares with the mid element, and accordingly searches the left array, and left array if it is less, correct, or if the item is greater, it is being searched in the right array, and if it is found, we simply print the index where it is found. So here it is present as 0, 1, 1th index, we have printed the index as 1. This is how the search algorithms work. Thank you. Have a great time and happy learning.